some more advanced data structures. In general, I want to talk about these 4 variable types. I actually want to start with the bottom one. I want to start with mappings, then go to structs, and then talk a little bit about arrays and why we haven't covered them in a lab. And then I want to talk about enums, which we haven't done at all yet. Mappings is the beginning of the previous lab, or was the beginning of the previous lab. They work like hash maps. If you've ever worked with hash maps, you start, or you define a mapping with a keyword mapping, and then you have the round brackets open, and then you say a key type is mapped to a value type, and then you give the whole variable a name. The key type can be pretty much any elementary type in Solidity. It can be uint, it can be Boolean, it can be addresses. We used addresses. And so it can be pretty much any built-in value type of Solidity plus bytes and strings. So you can, for example, say you want to map a hash of something to a value type. So for example, a hash to a Boolean, and just see if the hash was already transferred. The value type itself can be pretty much anything. So you can have structs as value types, you can have other mappings as value types, and so on. This is how a mapping would look like with an address mapped to a Boolean, where you can, for example, say an address is allowed to receive money, send money, interact with a smart contract, and so on. So this would be a classical yes-no flag. In our case, we had a mapping where an address is mapped to an unsigned integer, and we saved the balance that was transferred. And remember, in mapping, you don't have to initialize the value types or the values that you're mapping, because all values are initialized by default, which also means a mapping doesn't have a length. So an array has a length, and I will talk about arrays in a second, but a mapping doesn't have a length. And if you remember back in our struct, I used an index stored separately in order to map specific uints to a specific value. And if you want to have the length, then you have to store the length separately. If you have a mapping and you make it public, then you automatically create a getter function for that mapping, so you can access it like a getter function with one argument. And in the Solidity documentation, there is a mapping that is iterable, and it was implemented as a library, but we haven't covered libraries yet, so I'm not going to show you this example. If you're really interested, then open the Solidity documentation, solidity.readthedocs.io, go to Solidity in depth, and then have a look at the mapping example, and there you find the library. Structs are here to create your own custom variable types. You define a struct with the keyword struct, and then the name of the struct in capword style, and then the struct members are defined with their type and a semicolon, not a comma, a semicolon as the end of the line. And you can access struct values. For example, if you have a struct like this, a funder struct, and then you have a member called address, and you have this period in between the variable name and period or dot address and variable name dot amount, and also those values are initialized with their default values. Good to know is a struct member cannot have the same type as the struct itself, so it cannot be recursive, but you can have the member of a struct have the struct type of another struct, so you cannot have the struct inside the struct itself again defined. And in general, if you come from any object-oriented programming language, you would probably do something like this over here on the left side, where you have a contract which defines a specific class, and then you have public or in general variables and getter and setter functions for these variables. That would be like your model, and then you would use this model inside your contract or inside your other class. It works in Solidity as well, so this is not a problem. The problem is the gas consumption. So when you are deploying a new smart contract like this one, then you would need a lot more gas than deploying a struct like here on the right side, where you basically have you can achieve the same kind of data storage in your custom defined type as you would probably do it in your external class. That doesn't mean that there are not valid use cases for having data in external classes. For example, if you want to detach data storage from your smart contract into an external smart contract, but you have to be aware of the implications that it has on the gas consumption. You can use mappings and structs in combination, as we did. So you can have a mapping that maps an unsigned integer onto your value type, which is a myStruct type. And then you have your variable, and you can access this variable with sum var, and then you can access sum var with the brackets open, 0, brackets closed, period, var1. There are arrays in Solidity, and they can have either fixed or dynamic length. For example, if you have an array of the type T with a fixed size, then you write it like this: T, brackets open, K, brackets closed. Or you have a dynamic size array, T, brackets open, brackets closed. Or you have 5 dynamic sized arrays of the type T, then you would write it T, brackets open, brackets closed, brackets open, 5 brackets closed. This is in reversed notation. Be careful with that. It's usually better to use mappings instead of arrays, even though arrays are more intuitive to use because they have these two members, the length, and you can push elements onto your array and you can remove elements from your array. But the problem is the gas consumption. A blockchain, especially the Ethereum blockchain, is a low resource computational engine. So when you do something with arrays and you start iterating over arrays because of the length, then you will quickly run into gas problems. So usually I found it better not to use arrays. There are use cases for arrays and we will cover them, but not as in-depth as mappings and structs. Last one is the enums. The enums are also a way to create user-defined types in Solidity. For example, you can have these action choices where you start with the keyword enum, and then in capword style action choices, this would be your new type. And you have, for example, 4 choices: go left, go right, go straight, or sit still. This is coming from the Ethereum documentation, by the way. And then you would define a variable choice with the type action choices. And internally, Solidity will map those go left, go right, go straight, sit still to integers, unsigned integers to be clear. And it tries to fit it into the smallest unsigned integer range, which is uint8. So if you have 255 values, it will fit into uint8. So action choices or choices can actually be mapped to integers. So let's talk about the key takeaways. Mappings are like hash maps, and they are usually preferred over arrays. Everything in a mapping is initialized by default. You cannot really iterate over a mapping because it doesn't have a length unless you are defining your external data structures. And an example of this would be the library that is in the Solidity documentations. Structs allow you to define your own data types, and that is very cool and very important and a very highly used feature in Solidity. And if you combine them with mappings, you have a very powerful combination of data structures where you can do a lot of things very easily, very quickly in Solidity. As a last takeaway from this lecture, I want you to know that at this point where you are right now, if you understood mappings and structs and the rest of the other lectures that we went through, you should be able to read most of the smart contracts that are out there. So when you look at any smart contracts that are out there, you should be able to understand and read them and maybe use them even to the greatest extent that is out there. We haven't covered so far in detail the exceptions, and we haven't covered so far in detail libraries and low-level functions, but most of the things that are out there should be able to
Ok.
be easily understood by you now.
Rồi, thank you em.